complex numbers, if this quadratic equation here is solved using the quadratic formula, then the value of x is going to be -2 plus or minus the square root of b squared, which shall be 2 squared minus 4 into a times c, which is 5, everything divided by 2a, that is 2 times 1, which simplifies to -2 plus or minus, here the square of this one is 4, and the product of the all that is 20, so 4 subtract 20, we shall have -16, everything over 2. Now the square root of -16, we can try and split it, so that we shall have -2 plus or minus the square root of 16 times -1, everything over 2. And the square root of 16 times -1 is the same as the square root of 16 times the square root of -1. All right. And this one simplifies to, we shall have 2 plus or minus square root of 16 is 4, and then times the square root of -1, everything divided by 2. All right. This one can be simplified further. So -2 here divided by 2 is -1, plus or minus 2 here, 1, 2 here, 2. So we shall have 2 times the square root of -1. What you realize is that it is not possible to evaluate square root of -1 in real terms. So an operator, we are going to use an operator to represent that one, and the operator usually used in mathematics is j. So the operator j is usually equals to the square root of -1, so that the expression becomes, or the expression here becomes x equals to -1 plus or minus 2 times j, without forgetting the fact that j equals to the square root of -1. J here is used in mathematics to denote the square root of -1, so that the solution to the original quadratic equation here becomes now x is equals to -1 plus 2j, or -1 minus 2j. So those are the two solutions to x. These two values are called complex numbers. So the two values are what are known as complex numbers. The two solutions are of the form, we can say that the two solutions here, they are of the form a plus bj, where a is denoted, or it is known as the real part of the solution, or the real part of the number, while bj is known as the imaginary part. So in other words, we can say that complex numbers are numbers which have both the real part and the imaginary parts. Also, complex numbers of the form above here are called Cartesian complex numbers, and that means that they can be represented using what is known as Argand diagrams. Now let's look at one more example. Solving the quadratic equation of the form x squared plus 4 equals to 0. And when you have such an equation, then it means the 4 shall cross the equal sign, so we shall have x squared is equals to minus 4 because the sign here has to change when it crosses the equal sign. Now to get the value of x here, it means we are going to get the square root on both sides so that the square root here cancels the square. And what we have on the right hand side shall be the square root of minus 4, which is the same as the square root of 4 times the square root of negative 1. And when you get the square root, remember we have both plus or minus, and this one simplifies to plus or minus. The square root of 4 is 2, and then the square root of negative 1, just like we said, is equals to j. So the solutions here becomes x equals to 2j or minus 2j. Let's look at further examples. Like for example, if we are asked to evaluate, first one here, j raised to 3. Now j raised to 3 is the same as j times j times j. Let us first of all work out j times j. J times j is the same as, since j is equals to the square root of minus 1, then j times j becomes the square root of negative 1 times the square root of negative 1. And the square root of negative 1 times square root of negative 1 is the same as negative 1. For example, or for instance, if you're given root x times root x, according to rules of indices, square root of x is the same as x power half, and then multiply by x power half. And according to the product rules of indices, when you multiply two values, you add their powers. So we shall have x raised to a half plus a half, which is x raised to 1, which is just x, right? That is why we're saying j times j is the same as square root of negative 1 times square root of negative 1 is equals to negative 1. We also know that j times j is j squared. So it means that j squared equals negative 1. But since we were looking for j raised to 3, which is the same as j squared times j, then this one equals to j squared, which is minus 1, times j, which is simply negative j. So in other words, we are saying j raised to 3 equals to negative j. One more example we can look at is j raised to 4. We can split this one into j raised to 2 times j raised to 2. But since j raised to 2, like we've seen here, j raised to 2 is negative 1. So we can say that this one is negative 1 times negative 1, which is equals to 1. So it means that j raised to 4 equals to 1. Let's look at one more example. If you're told to evaluate the value of minus 4 divided by j raised to 9, right? Let's first of all evaluate j raised to 9. And j raised to 9 is the same as j raised to 8 times j raised to 1. Expressing j raised to 8 in terms of j power 2, and we are going to try and apply the power rule of indices, whereby if you have a raised to m, everything raised to n, then it means you multiply m times n. So it means a raised to mn is the same as a raised to m, everything raised to n. So this is what we're going to try and employ here to split j raised to 8 in terms of j raised to 2. So I shall have here j raised to 2, everything raised to 4, because 2 by 4 equals 8. And of course, this one is multiplied by j raised to 1. But since j raised to 2 is minus 1, then it means the whole of this is -1, everything raised to 4 times j. Since -1 is raised to an even number, then it means the answer will be 1 times j, and the answer becomes just j, or 1j. 1j and j is just the same thing. So it means that j raised to 9, it means that j raised to 9 equals to j. But from the original question here, we are told to evaluate -4 over j raised to 9, which is just j. From here, we don't leave our answer at this point, but we multiply this one by the conjugate. The conjugate, remember in radicals, the conjugate as used in radicals. So we shall multiply by the conjugate of j. Since j here is positive, we shall multiply by -j over -j, which becomes -4 times -j here becomes 4j, and j times -j is -j squared, right? So this becomes 4j over negative brackets -1, because j squared is -1. This one simply writes to 4j divided by 1, positive, right? Therefore, it means that the expression -4 over j raised to 9 is simply equals to 4j. Thank you for watching, and see you in the next one.